So good morning, everyone, and welcome back to PPS online sessions. We are continuing here, programming for problem solving. That's what the subject we are continuing. And yesterday's session, we discussed what are the contents we are going to cover in this entire semester. So we looked at, or we had gone for the bird eye view on the syllabus. Some of the topics we discussed. Then we looked at the practical list, then flow of the content, teaching scheme, how you are going to cover your marks, some of the reference books, and before we ended the session, we had also seen online resources, some of the links. Well, I will upload that syllabus file in the e-content today. So you will find that PDF file from your student login. And probably by today, your yesterday's session will also be uploaded, and you will have the link of that recording from your student login by end of the day today. Fine. Well, so let's start our syllabus. Unit number 1, Introduction to Computer and Programming. Well, if you remember, unit number 1 is all kind of a theoretical part, right? And C part from number 2. Now let's go through unit number 1. It is going to be totally theoretical. We are not going to start any of the practical here, but maybe in lab sessions we will start a little bit of practicals. But when we start unit number 2, before that, I'm going to show you all the editors, IDEs, compilers that you may use. Even if you are using mobile, then I'll show you some of the online websites where you can write your C code and run it. So before we start that C programming language, I'll make you aware of every possible ways. But for now, it's not needed. And let us go through some of the points of basics of computer and what is the programming. Yeah. So that's what we are going to start today. So this is the unit number 1 highlight. Introduction part, block diagram, then concepts of hardwares and softwares, types of softwares, then compilers, interpreters, concepts of programming languages, and the thing that we are going to follow this entire semester is flowcharts and algorithms. Now this is what the content we need to cover here. But as you can see, many of you will be aware of these terms. So what I expect from you guys is let's have this unit based on an interaction. So I want from you guys and answers, or whatever you think, whatever comes to your mind, just type it and send it to the chat box. So whenever we discuss something here and anything comes to your mind, you can post in the chat box always, right? So what is computer? Well, computer is nothing but an electronic device. It's actually the combination of hardware and software, right? All the hardwares that we can touch, we can feel, everything. And it's kind of, let's say, your keyboard, mouse, screen, whatever, everything that you have on your desk can be considered as a hardware. And the software, which we cannot see directly, but it runs inside the hardware, inside the computer. It's a logical part. It's not a physical one. And without software, none of the hardware can operate. That's also true. And without hardware, we cannot run any software. So there is a dependency, right? That's what the computer is built of. But this is the main basic block diagram of any computer I'm saying, right? Yes, Saurav, it's correct. CPU, monitor, keyboard, all these are the hardwares we can consider. Now, the basic block diagram here, as you can see, always you'll have input section or input hardwares in any form. Look, keyboard is one type of input hardware, mouse is one type of input hardware. If you have laptop, then touch let's say touch bar, or let's say touchpad is one kind of input hardware. If you have a touch screen, then that screen also works as an input device, right? So from any form of the hardware, we give some input to the system. Now that input goes to your CPU. Look, I'm saying CPU. This is not the entire cabinet or the entire thing. CPU is a processor. That input goes to your processor, central processing unit. Now it consists of ALU, MU, and CU, arithmetic logic unit, which is responsible to perform all the arithmetic operations as well as logic operations. Now arithmetic means whatever summation, subtraction, multiplication, division, or any kind of arithmetic operation you want to perform. And logic is something like you have condition whether this thing is true or not, true false kind of thing, logic part. So that kind of calculation is going to be executed by this section inside your processor, ALU. Then you have a memory unit, main memory unit inside your processor. It's responsible to store some data. So anyway, if we want to perform something, then we need to have that data, and that data might be coming from input or might be coming from secondary memory, your hard disk, or somewhere, right? So we have some memory where we have a data. We take this data and perform some operations in ALU. Now then we have a CU, control unit, which is responsible to control all these things, right? So it controls the every part in your computer. And then once you have some output ready, you are going to display it. You may display or you may send it to other device or anything that may happen, right? So you have output section. Output section is output device, maybe your screen, your projector, or maybe some kind of a, LED blinking device, anything where you can have some kind of a feedback or acknowledgement, or that thing can work as an output section. And apart from this processor, CPU, we have secondary memory also, which is nothing but your hard disk, external hard disk, or even inbuilt but hard disk, which is not part of your processor. So that's the secondary memory, okay? Now, Dharmik is again asking difference between ALU and MU. Look, ALU is responsible to perform operations. Arithmetic and logic operations will be performed inside ALU. MU is responsible to store your data, memory unit, okay? So it will only store your data. If you say that I want to perform 5 plus 3, then from input section you are going to send 5 and 3. Now that data 5 and 3 will be there in the memory unit. Control unit identifies, okay, what we need to do here. Okay, fine, we need to perform plus operation. So 5 and 3 will be sent to the ALU. ALU knows what is plus. So it actually sums up those two numbers coming from MU. And 5 plus 3, you have the answer. Now, depending on your code, if you are going to display it on the screen, then it goes to the output section. If you are going to store it somewhere in your secondary memory, then it goes to the secondary memory in your hard disk and it will be stored there, right? Now, MU is the memory unit which is part of your CPU, right? A cache memory, whereas secondary memory is the permanent memory that we thought of, which is hard disk or external hard disk or your SSDs and so on, right? So that's what we can do here. Well, this is a very basic block diagram, and possibly if anyone wants to go for easy question, then this may be asked, what is a block diagram of computer, and explain it. So First of all, you need to draw this diagram, and then you need to explain each and every part of that diagram. So what is CPU? CPU is nothing but a brain of your computer. It's a processor which consists of ALU, AMU, and CU, right? Main purpose of the CPU is to execute all the programs, perform all the tasks, right? Now then you explain what is ALU, what is AMU, what is CU. So arithmetic logic unit is responsible to perform all the arithmetic operations, plus, minus, into, divide, and so on, as well as logic operations, so and or not operations will be performed inside ALU section. Then what is CU? So it's a control unit. It is going to control, okay, it is going to control your ALU as well as MU. It is kind of creating a bridge between those things, right? It controls all the activities within your CPU. So as well as all other devices which are connected to your processor, your CPU, let's say. Keyboard is connected, mouse is connected, screen is connected, and other printer is connected, and so all those connected devices will also be controlled with control unit, CU. Now it mainly has two parts. One is the instruction register, and the other one is the program counter. Now using this two, it is going to control everything. Program counter is kind of a pointer, where am I right now? So if I pass in 10 different instructions to the CPU, okay, if I pass 10 different instructions to my CPU, then control unit has a program counter which actually maintains which instruction I am executing right now and what will be the next instruction I should follow, right? Then instruction register, it contains the instructions. So if I'm giving 10 different instructions, then IR is the thing where all the instructions are stored. Look, instructions are not, what we do is we pass in those instructions in a simple language, programming language. But when we compile our program, those instructions are going to be converted in the machine level language. So later on, later part of your journey in the engineering course, you will see, you will learn operating system subject. Then you will see, you will also learn few other subjects, system programming. And in that thing, you are going to deep dive and see what instructions are and how computer understands those instructions and in which form, right? But right now, what you should remember is control unit will have instruction register where you are going to store your instructions. Program counter is going to manage that pointer, where am I right now? Okay, I am at a first position, then second position, then third position, and fourth position, and so on, right? So that's what the CU is. And the MU, now question comes from multiple students. What is MU? What is the part of MU? Then the memory unit or the main memory, what we talk of is gonna be the RAM, it's gonna be the ROM, PROM, EPROM, anything from this one. Random access memory, read-only memory, or programmable read-only memory, erasable or electrically erasable programmable read-only memory. All these are part of main memory, which is a part of memory unit. This is going to be volatile memory. Okay, once you shut down your computer, all these things are going to be wiped out. Fine. So some of you have already asked, sir, is my RAM going to be part of memory unit? Yes, it is. Okay. So all these RAM, ROM, PROM, or whatever you consider is going to be part of your main memory. Or simply to understand, volatile memory will be the main memory. Volatile means it's going to be erased once we shut down our system. And when we start our system, it will be blank. It will be loaded some instructions, some programs, and then will be executed. Right? Now, what are the input sections? well, some of you are asking what is the diagram one more time. So, well, this is what the basic diagram we have. We give some input to CPU, it performs some task and gives us the output. CPU may require secondary memory to be accessed, which is the hard disk. So it can have two-way direction with the secondary memory, right? And CPU has ALU and MU. So control unit is going to control everything based on the instructions. ALU, arithmetic logic unit, is going to perform your task. But when we are performing any task, we need data, and that data will be coming from the main memory unit. So this is the diagram, right? Now coming back to RAM or the memory unit, semiconductor material. Well, electronic devices does make use of semiconductors. It's part of electronics and communication, right? If you know diode, right, that's what the semiconductor is. So using semiconductor material, these memories are actually built, and those requires continuous power to store data, also wiped out. That's what the semiconductor behavior is, right? So that's what the memory is. Now, what is input section? Well, any kind of input device, keyboard, mouse, touch screen, or touchpad, or even your scanner is kind of an input device, because we scan something and pass in that scanned image to the system. So that also works as a input section. Everything from where your CPU can take in some data is going to be input section. And the output section, example, is monitor, printer, your screen, speakers, right? Now, anywhere where your CPU can post that data can be considered as output section, right? Jwalant is asking any IDE, the output is in PROM. Well, depends. Not exactly the PROM. IDE is a different than the RAM or memory unit. IDE is just a software, integrated development environment, IDE. Okay. Now, what it does is it is going to store your answers in the RAM, simple RAM, that your computer has, right? And when you close that IDE, everything will be wiped out from your RAM. So it's a simple RAM. Software may or may not require PROM, EPROM, EEPROM, but that depends on the configuration of your system. Fine. Yeah. So let's continue. Secondary storage devices, which is nothing but our hard disk, floppy disk, CD, DVD, pen drive, SSDs, or whatever we have, where we can store our data permanently, right? Not exactly permanent, but for a longer period of time, we can say. So those are going to be the secondary storage devices. Now we have a few more questions. Detail about ROM. Look, ROM is just a read-only memory. You cannot write on that. It's only readable, right? You can only read that data. You cannot write it. So that's read-only memory. RAM is random access memory. You can read and write, doesn't matter. And even you can read in random access. So our RAM, whatever system is, because sometimes we work on a text editor, then sometimes we work on the let's say some program, then sometimes we work or in a background, let's say one music is going on and so on. when we have multiple cores in our system, those cores are performing the task parallelly, and they need some data from different places from the RAM. So it should be random access, randomly accessible, right? So that's how it goes. Secondary storage, as we have seen, hard disk, floppy disk, and CD, DVD. Now, we make use of hard disks up to some extent, but nowadays SSDs have been introduced, solid state drives. Hard disk is something that has a magnetic device. It's a magnetic device. It has number of platers. Platers are nothing but kind of disks, okay, magnetically created disks, and it has number of headers which will move to and fro direction on that plater and read or write data. That's how hard disk works. SSDs are nothing but purely electronic device. Hard disk is a mechanical device, whereas SSDs or pen drives are purely electronic devices, right? CDs and DVDs, we all know. We have CD, we have DVD, we have Blu-ray discs, and so on. Floppy disks are kind of a, we can say now it can be seen in just a museum maybe, but earlier floppy disks were used majorly. Floppy disk is kind of a CD, but look, CD is optical device, whereas floppy disk is again a magnetic device. It has a magnetic, not a plate actually, but material which can store your data. Floppy disks were very much viable earlier. At any point of time, your data may be lost, and that's why it was not carried forward, and we have other ways of storing our data, right? CDs and DVDs are optical drives, so it's kind of material where optically we are going to read data. So it has zeros and ones. It's kind of आप कुछ ऐसे सोच सकते हो कि एक प्लेन रास्ता है जिसमें खड्डे हैं. Well, आप just visualize that thing. It's not going to be the same way, but अगर खड्डा है तो जीरो, खड्डा नहीं है तो वन. आप कुछ ऐसे सोच सकते हो. And what the CD DVD readers are doing, they have a optical reader part, header, which is going to float a light, and it is going to detect that zeros and ones based on the light intensity, and then it can interpret zeros and ones to the data, convert it, because computer always understands zeros and ones, binary format. Yeah. So, well, Shivani, recording is on here. It's okay. It's going on. Yep. So let's continue. So that's what the secondary devices are. Now we may also go for hardware and software comparison. Now what I want is you read this slide carefully, understand everything, and then let's have some kind of discussion here. What is hardware, what is software, and what you think, what comes to your mind when I say hardware or a software. You can also read these part. What I want is, I don't want you to copy and paste these statements. I want your interpretation. What do you mean by hardware and what do you mean by software? You can have your idea from this slide, read it, understand it, and throw your views. by the time, let me have a look at few of the chat, so I can also answer those queries. Well, Vyom is asking about SATA and M2 and all those things. Well, that's not part of our content right now, so let's not go through that part in running sessions. But sometime, if we have extra sessions, then we'll consider that thing also. I'll tell you what is SATA, what is M2, what is how SSDs work, what types of SSD we can have, and all those things, right? Hers is asking what makes SSD to make operating speed so fast? Well, it's a solid state drive, totally electronic device. So it can work fast. It does not have any kind of a mechanical part. That's why it works faster. Read and write works faster than the hard disk. Vyom is asking, sir, what actually happens when hard disk crashes? Does it happen with SSD too? Well, it can happen. What do you mean by crash? Look, when we say that it is not being accessible or our data has been lost, we call it crash. Hard disk may crash, SSD may also crash. It's an electronic device. Even SSDs have their lifetime, the number of read-write operations, right? And nowadays current SSDs have enough lifetime, which covers the entire span of our system. So need not to be bother of that thing, but still it has a lifetime. When we say it crashes, so maybe due to any kind of damage, it is not being accessible. Hard disk may happen or may crash. And there are ways to recover data. If it crashes, then we can repair it or we can recover our data. It is possible. That depends what kind of damage has happened. Okay, so data recovery may depend on what kind of damage has happened to your storage device. Okay, Mike is saying yes, software is a collection of codes installed on to your computer's hard drive. Well, software is, we can say software is nothing but a collection of instructions, nothing else, right? When I say that you perform this task, okay, when your friend, your parents, or your faculty, teachers sometimes instruct you to perform some task. Now that's your task, but how do you perform? So to perform that task, we have a set of instructions. First you do this, second you do this, then this, then this, then this, and so on. That step-by-step instructions are actually algorithm. But when we implement those instructions in any kind of a programming language, then it becomes a software. Okay. Pankaj is asking, primary storage data stores data in binary. Yes, at the end, it is kind of a binary, zeros and ones. Format of that binary data may depend on a device, what kind of device you use. At the end, it is going to be zeros and ones. Hardware is physical, yes, hardware is physical, we can touch it. Can a computer run without software? Saurabh is asking. Well, no. Because look, if you do have your hardware, then you also need to have a driver, someone to drive it. And software is a thing which is going to drive it, because software has those instructions. Yeah. I mean, you may have a four-wheel car standing outside your house, but it's not going to run by itself. We need to have a driver for that, who knows all the tasks or all the instructions. We need to press clutch first, and then we need to change the gear to first gear. Then we need to slowly pull up the feet from clutch and accelerate a car, and then it goes straight. We do have a let's say steering wheel to control it and so on. So those instructions are software. The one by one instruction is an algorithm, but when we implement it in our mind, that's the software. And we are actually the control unit. We are controlling that thing. Yeah. Dhamik is saying a physical device which work with computer or any other machine is a hardware, we can say. What a software program requires maintenance, or else it is just upgrading in the maintenance. Well, yes, softwares also do require maintenance, because maybe technology is being changed day by day. Hardwares are getting older day by day. New hardwares are coming. Compatibility issues may happen, and that's why we require, okay, that's why we require to maintain our software. Fine. So that's what we can say. Now, when we maintain our software, we may have minor changes, or we can have a new version also. So we may follow versioning system. That's what all the softwares do follow: version 1, version 2, version 3, version 4, and so on. We do have operating system versions, we have application versions, we have desktop software versions, and so on. Primary storage stored data in binary. Yes, we have gone through that. Software make upgrade and some maintenance. Why? Look, Arnav, I believe I have given this answer. Because of dependencies, compatibility issues, and new technologies, we also need to update our softwares. Okay, Aryan is asking what happens when file or data gets corrupted. Look, when we say it has been corrupted, means what? If you store your file in let's say secondary storage device, it has been stored in the form of zeros and ones, let's say. Now, because of some reason, let's say from the sequence of those zeros and ones, some of the bits has been changed. Maybe because of any kind of damage to your hard disk or any kind of a storage device you have. Now, if that sequence of zeros and ones has been changed, then when we read that data, sequence of 0 and 1, we will not be able to properly convert that sequence of zeros and ones to the actual data that we want. Okay. Let's say we want to store Marwari University in the hard disk. Then what we do is we convert that text Marwari University to the sequence of zeros and ones. How it can be done? You will learn that part in the journey of your engineering, right? How those characters are being considered. What is the character? How we can store that character inside the memory. What is the memory? It is nothing but sequence of zeros and ones, and those zeros and ones are stored in the hard disk. So Marwari University will be converted to the sequence of zeros and ones. Now, if that sequence of zeros and ones has been changed, then when we convert it back to the string, we will not have the original Marwari University, we'll have something else, maybe some kind of special characters and all those things. So we can say it has been damaged or it has been corrupted, our file has been corrupted. Now, if the file has been corrupted, then the software that we use to read that file will decide that thing. Okay, if that software successfully reads that file, then it will display the output. If software is not being able to read that file properly, then that software will give you the message file has been corrupted. And why software cannot read? Because the sequence has been changed and data has been changed. Okay. Then Krunal is saying hardware is not be transferred from one place to another through network, but software transferred network. Yes. Kunal is trying to say that you can transfer your entire software through the network. Well, because it is a logical part and it's nothing but kind of a data, kind of a file. Code is just a text code or the text syntax or text file. You can transfer it through the network. Now, hardware is a physical thing which cannot be transferred over the internet or over the network. Physically, transfer should happen for hardware. Can we say PDF is ROM because we can only read it mainly? Look, PDF is a format. Okay. When you are using this analogy, read only. So yes, PDF is kind of read only, but it is a file. PDF is a format of file, whereas ROM, we are talking about memory. Okay. Mouse is hardware, but mouse pointer is software. Look, mouse is definitely a hardware, Viraj. But mouse pointer, look, mouse pointer, to display a mouse pointer, whatever code we have written, it is a software. But whatever pointer you see on your screen is actually the output of that software. Okay, so let's understand this thing using another example. For example, you have or you are about to calculate your result, fine? You are going to calculate the result of your first semester exam. Then the calculation part, where you have the total marks obtained, then you have the total marks of subjects, then you find out what is the percentage. Based on the percentage, you define the grade and so on. Now that entire process, when you build it, it is a software. But when you run that software and on the screen you have 90%, then 90% is the output. Okay, 90% is the output. So this cursor, the cursor that you are looking at on your screen is actually the output. 90% cursor. But behind the screen that makes this happen, okay, the code which is being run behind the screen on your processor, inside your processor, is actually the software. Then we have beyond. Hardware is made by electronic engineers and software by computer engineers. So what about IT people make? Well, computer engineer, do not consider it as a CE branch. Okay, even IT engineers are, we can say, computer engineers. We have two different branches because we have a certain field separation between CE and IT. Computer engineers are more or somewhat lenient towards the internal structure of the computer. They do learn some of the subjects which covers internals of the computer, whereas IT students or IT branch is more focused on purely the software and the communication being done between number of systems. So that's the minor separation line between CE and IT. Otherwise, you'll never find any difference between CE and IT. Even you go for further study, CE IT is common. Even if you go for industry, CE IT, both students will go for the same placement drive. Everything is common. Even when you go for masters, okay, then there is nothing like CE and IT. Masters, if you go for masters, CE IT student will sit together and have the master's degree. Fine, Vyom. Yusuf is asking how are software engineers, just a minute, yeah, how are software developing software made? Well, I'm not clear with your statement, Yusuf, but what I can understand is you are about to ask how softwares are created. Well, in that case, we are going to learn that thing in this semester itself. We are going to create a software using C language. Now, definitely, right now, your software will be the smaller one. A small software you will create. Software is nothing but a code, right? When you write your C program, you can say it is a software. If you create a C program to calculate your result, it is a software which calculates the result. If you write your C program to perform, let's say, calculator operations, then it is a software which is being called calculator. But it's a smaller software. Now, eventually, when you develop your logic, and when you learn few other programming languages which can handle larger amount of code easily, then you will be able to create larger softwares also. How we cannot see the software? Point second. I don't understand, Abhijit, but I believe you are saying that we can't see the software. Well, software is nothing but the code, as I have already said. We can see that software code, but we cannot see that software running inside the processor, right? Whatever code we write, it's a row or the we can say the original code instructions. But what we write is the instructions we write in some kind of a programming language. When we compile that program, it is going to be converted to the machine understandable code. And we cannot understand that machine understandable code. Only machine understands that thing. Horst is saying both hardware and software are equally important. Yes, it is. If we make heavy software or games, then to resist those heavy graphics, we need better hardware. Definitely, Horst. Hardware and software, they are closely bind together to create a system, and those two need to be compatible with each other. Otherwise, your system is not going to work properly. Well, let's go on further now and have a look at this slide. Let me elaborate this slide a little bit. Hardware is a physical component, we can touch it, whereas software is a logical component, we cannot touch it. Whatever you write on your screen, right? You feel that you are touching that code, but you are actually touching your screen. You are not touching that code. That code is there somewhere in your memory or in your hard disk. We are not touching that part. We are touching our screen. So that's why I say that we cannot touch the software. Whenever we touch, it is either going to be screen, but not the software itself. So, well, hardware is divided into multiple parts, microprocessor, motherboards, other peripheral devices, keyboard, mouse, screen, printer, scanner, and so on, right? Examples are given here. Whereas software is divided into multiple categories like system software and application software. We will see those types of software after this one. So system software is something which is needed to run our system, like operating system or the drivers for all the peripheral devices and so on. Application software is something that makes our task easy, like Microsoft Office. We make use of Office software to make our task easy, to write reports, to make presentations and so on. That's one example. VLC player makes our task easy to view movies or videos, right? MP3 player makes our task easy to listen something. All those are the application softwares. So it is based on the application that we want to perform. Hardwares are electronic components, whereas softwares are a collection of programs. Collection of programs because small programs can make a software by combining together and so on, right? Hardware requires maintenance, screwdriver, tester, and hardwares, right? Software also requires maintenance, but that maintenance not be physical one. It's kind of a software maintenance, testing part and upgrading part, updating part, and so on. All the hardwares will require special kind of software to make it run, right? And software for design, it requires a system software. So operating system is the best example for system software. To make your system run properly, everything works properly, we require operating system. One kind of operating system we need to install first. Then and then only we can boot up our system and we can have desktop and everything, right? So hardware is just like a car, software is just a driver for that car. I've given this analogy example already. And then we have few examples here. Yeah. Well, so it's almost time, 11:26. Let's conclude this session, but before we conclude this session, let me quickly have a look at few of the chats. If anyone is asking something, then I'll explain. Well, difference between script and code. Harsh, you're going to learn programming languages and scripting languages both throughout your journey in the engineering. So at that time, you'll be able to understand. For right now, if you want me to explain, then in a very short explanation, I can say programming languages need to be compiled, whereas scripting languages need to be interpreted. That's the major difference between these two. One need to be compiled, another one need to be interpreted. And we do have difference between compiler and interpreter here later on. So at that time, we'll discuss more. Sir, how to make our own programming language? Well, programming language is nothing but kind of set of rules, like Gujarati language, English language, Hindi language. All those languages are having set of rules, grammars. So we can also develop our own programming language, set of rules and grammars, and give some kind of supportive software. Again, compiler is nothing but a system software. So we need to give a compiler with that if we want to create our own programming language. Virus and malwares, etc., are binary digits. Well, viruses and malwares are nothing but a softwares. We call it virus because it is actually going to affect our system in a bad way. So we call it a malware or virus. At the end, it is a software. What is big use of graphic card in laptop or computer? Like dedicated graphic cards, integrated graphic cards, and so on. Viraj is asking. Well, the basic block diagram that we have seen consists of ALU, arithmetic and logical unit, which is responsible to perform arithmetic task or logical task. Now, it can do some point of graphic work, but it does not have that much capability of doing graphical work quickly. Now, graphic cards are built specifically to perform graphical work. Now, at the end, graphical work is again mathematical task, but it has a capability of doing that graphical mathematical task very fast, very speedy, and that's where we need graphic processors, graphic cards. So something like, look, we have normal cars and we have cargo vehicles, right? We have a normal car vehicle and we have a cargo vehicle. Car can also transfer your goods, but it does not have that much capability, and that's why what we do is we create a cargo vehicle where we can load multiple or more amount of goods and we can transfer it. And that's kind of separation you can have here in CPU and GPU. Now, software made where we write code or language, simple text editor, Manav. We are going to write our code on any text editor, and then we'll save that thing. When we compile it, it goes to the system. Yeah, so let's conclude this session here because we need to end this session. We have another session at 11:30 sharp, so I need to end this session. We'll discuss on these things later in the next session also. Thank you, everyone. Thank you for being part of this session here, and see you in the next lecture. Thank you.